Okay, so today we're going to talk about piecewise functions. We've actually already learned this, but this is going to be like a quick review. Piecewise functions just mean that it's one function with multiple equations because it has a domain restriction. This means like for specific x values, we use a specific equation. For example, here I use 2x minus 1 when x is less than or equal to 3, and negative x plus 3 when x is greater than 3. So for example, if I wanted to find f of 2, I would use the first equation, 2 times 2 minus 1, and get 3 because 2 is less than 3. So that's the equation I use, okay? So in order to graph these, the first thing I have to identify is the domain restriction. It's the most important part because this is where my graph changes. So at 3, I make myself a line so that I know that some sort of change is gonna happen because it's my domain restriction. So I make a table in order to graph this, right? I'm gonna make a table of values like usual. And we want our x values here, our outputs. Now, the most important number is the domain restriction. So 3 is the number that has to be in the middle for me. So I do a couple numbers before, let's say 0, 1, 2, 3. And then I need to repeat 3 because it needs to be used for both of the equations because it is my domain restriction value. So my endpoints are gonna be at 3. So I do 3, let's say 4, 5, maybe 6, and then I can stop, okay? Now, when I'm from 0 to 3, this is when x is less than 3. So the equation I'm gonna use here is 2x minus 1. And these numbers are when x is greater than 3, 3, 4, 5, 6. So I'm gonna use negative x plus 3, because that's what it tells me to use here. So here, I want to think one of these is going to be a closed circle and one is open. When I use this one, 2x minus 1, it's less than or equal to. So this 3 is going to be my closed circle, whereas this 3 is going to be my open circle, because it's just greater than, not equal to. So if I were using 3, I would use this first equation, not the second one, because that's the one that's actually included in the solution. So what I do is I fill in my values. 2 times 0 minus 1 is going to be negative 1. 2 times 1 minus 1 is 1. 2 times 2 minus 1 is 3. And then 2 times 3 minus 1 is 5, and I can graph that. 0, negative 1, 1, 1, 2, 3, and then 3, 5, and I remember that that is my closed circle, so I'm just gonna remember a closed circle there. And this is when x is less than 3. So that's less than, so left. So I wanna keep this going to the left because the left side is when the x values are less than, and that's where this part of my equation would continue to the left, okay? But I'm not done because I still need to do the second part of my equation for what's gonna go on the right side, what's gonna be when we're greater than 3. So I substitute in again. 3 plus 3 is 0. Negative 4 plus 3 is negative 1. Negative 5 plus 3. So, first thing I'm going to do is 3, 0. Now 3, 0 is an open circle because it's not equal to, and we want this to still be a function. And then I keep going, 4, negative 1, 5, negative 2, and so on. And this, since it's when all the values are greater than, is going to continue on to the right. So now we see I still have this function. It's broken because there's 2 different lines, but it's still a function because this is a hole and this is the actual point here. Okay, so we can do another example really quickly. Let's look at this one. So we have a new domain restriction, always the first thing I find. At negative 1, so I'm going to put it on my graph really quickly because I know that this is where the change is going to happen. I make my table. So I know my x values have to be centered around -1. So I do a couple values before -1. Let's say no, we should go lower than that. -4 maybe, -3, -2, -1. And then I repeat it because it's the domain restriction, -1, 0, 1, 2. Okay, and when I'm less than -1, I know I'm using x squared. And when I'm greater than -1, I know I'm using -x plus 2. Okay, and I do the same thing. This one is the open circle, not equal to, and this one is the closed circle because it is equal to. So I start plugging in my values. -4 squared is 16, -3 squared is 9, is 4, and -1 squared is 1. Well, 16 is not going to fit on my graph, but the rest do. -3, 9, -2, 4, and then -1 with my open circle is going to go at 1. Since I know this is a quadratic function, I want to make it a little curved if I can. And it goes up and to the left because this should be going to the left. It's less than, so it goes in that direction, less than. Okay, now we do the rest. -1 plus 2 is 3. -0 plus 2 is 2. So I can quickly do -1, 3. This is my closed circle because it's the real one. 0, 2, 1, 1, 2, 0. And this, because it's greater than, is going to continue down and to the right. Okay. And we see the same thing. It changes at the domain restriction. One side goes to the left, one side goes to the right, and that is my piecewise function.